So when you're finding out the inverse of the function, like as far as the AS level syllabus is concerned, now first thing that comes to our mind is uh, the process. Now, what you need to know is the process for finding inverse. So basically, when you want to find out the inverse, the first thing that comes to our mind is the process. Now, in our IGCSE curriculum, what we learn is to find the inverse, we actually interchange x with y. So let's say I'm giving a simple function, f of x is 3x plus 2. Uh, and what I'm doing is I'm finding, let's say, inverse of this function. Now for us, this is f of x is your y value, and that's 3x plus 2. Now, when you want to find out the inverse, you interchange x with y. So x become y and y become x. It becomes 3y plus 2. And you get 3y is x minus 2. And so you get y is x minus 2 over 3. So this function that you got is actually referred as f inverse x. This is f inverse x function. Now x minus 2 over 3 is the f inverse x. So now, what's the relevance of this? Now, when you talk about the inverse function, actually what's happening? So let us just try to see if I find out f of 1. Now, f of 1 for the function will be 3 times 1 plus 2, which is 3 plus 2, which is 5. That's your f of 1. Now, let us try to find out. So basically, the coordinate is 1, comma 5. When I put x is 1, y coordinate is 5. Now, if I talk about the inverse function, when I plug x as 5, let's say if I take x as 5, let's see what do we get y value is. So 5 minus 2 over 3, that becomes 1. So you can clearly see that the point that was 1 comma 5, that is becoming 5 comma 1 for its inverse function. So in inverse function, actually the logic of interchanging is that since the coordinates actually get switched, that's where we interchange x with y and y with x. But the entire key concept that you learn about finding inverse, you can't just find out the inverse of any random function. Now, logically, first, before we go ahead to the root of the inverse function, we need to actually understand the general idea of graphing inverse function. Now, when you talk about the basic function, like here, I'm just going to draw the x-axis, which is, let's say, this is x-axis, this is your y-axis. And now what I'm going to do is I'm just going to draw the line that I've drawn here, which is 3x plus 2. So 3x plus 2 is a line that cuts y-axis at 2, 0, comma 2, because the c value you can see is 2 here, y-intercept. And it cuts x-axis at negative 2/3. So it cuts x-axis at negative 2/3. So my approximate graph for the function, original function, is something like this. This is the graph of the original function. Now, when I'm graphing its inverse function, let's just graph this one, which is basically, let's say, x, I can just do is like x over 3 minus 2 over 3. So here the y-intercept is negative 2/3. So it cuts the y-axis now at negative 2/3. So this inverse cuts at negative 2/3. And if you equate this to 0, which means that you're finding where this graph cuts x-axis, it will cut at 2, comma 0. If I plug that. And you can see that in inverse function, the x properties are becoming y properties. So the y-intercept or the y value where the graph was cutting, I mean, the original function was cutting y-axis, now that becomes the x-intercept. The x-intercept becomes y-intercept. Now, this is the meaning of actual exchange. Now, when you talk about the inverse function here, it will be looking like something like this. So approximately, it should have passed through. I'll just redraw this. So it should look like this. Now, this is the inverse function. Now, when you talk about the inverse function, now it's important to actually see to it that when you're drawing the line, now if you see here, it's actually if I draw y equals to x line, now this is the y equals to x line, and this graph that you've drawn for inverse function, this is the f inverse x graph, and this is f of x graph, is actually, they are reflected in y equals to x line. So if I reflect this part of the graph in y equals to x line, it comes here. If I reflect this part, it goes here. So that's how you get the inverse function. So logically, when you're finding the inverse function, the transformation or the graphing skill that you need is to reflect the given function in y equals to x line. Now let us just talk about one more type of question. Let us just take one more graph where we are, let's say, graphing the inverse function. Now let's say this is the function here. Now I'm just graphing this as, this is my function, 0, 5. So inverse now, when I graph will be 5, 0. I'll cut the y-axis, this is cutting y-axis. Y-axis at 0, 5. So x-axis will be at 5, 0. And now if I draw y equals to x line, my inverse function, you'll notice, is something like this. So inverse function, when I'm drawing, it will be somewhat reflected. It's like a mirror image. It's a mirror image of your original function in y equals to x line. Now, what might happen is that it's really important that you understand the concept of function. Like, what is a function firstly? Like, okay, you input, let's say there's a function as a machine where you input x values and you get output as y values. Now, function always follows a rule in order any relation. Like, for example, I'm writing here, let's say I'm writing y equals to 3x plus 2, or y equals to y square equals to x square plus 4x plus 2. Somewhere x and y are being related. But these might be just relations. These might not be functions. So what is the criteria for a given graph to be function, or given relation to be function? Now remember that. Now, if I have a graph of a function, like let's say here, and if I draw vertical line and it cuts the graph at only one point, then it is a function. And if I draw a graph and then vertical line and it cuts at more than a point, which you can see here, then it is not a function. Okay? Just coming a little off track, like of what we were discussing just now. Why we can't have, why we one x can't have more than one y value in order to be a function? So it's a logical thing is that we're using functions for realistic and real life calculation. So when you look at, let's say, number of COVID cases at a particular time in India, there can't be two values at the same day. So if there is we are following a statistical analysis of one particular like company or one particular data source, then I can't have two number of cases, COVID cases in the same day. I can't say, okay, there are like 500 cases and there are like another like 600 cases in the same day. So the realistic parameter is that y actually we can't have two y values, I mean, or more than one y value for one given x value is this, that we use functions to model the real life quantities. And let's take some examples to actually see whether a given relation is a function or not. So now in this case, I've been given a graph and we want to identify whether the given relation is a function or not before we go and dig deeper into the inverse function. So when I go into here and you look at, if I draw a vertical line and it cuts the graph at one point, we call this as a function. So this relation, whichever x and y relation holds, is a function. Now when I draw vertical line here, it cuts at only one point. It is still a function. But if you look at this one, it has got one x has got two y values. That is not possible. So this is not going to be a function. And in AS level or in additional mathematics, you need to understand this concept before you go to inverse. So a function, a given relation or a given graph is a function only if it passes something called as vertical line test. So now let's just go back to our initial explanation about the inverse function. is when you look at the general, let's say the graph, I'm giving a general graph. Now we're going to go deeper into the inverse function. Let's say I'm finding out the inverse for a quadratic graph, a simple parabola graph. Now, when I'm finding inverse for this graph, and now since we just learned that, we sketch the inverse by reflecting in y equals to x line. So if I draw y equals to x line is here, and now if I draw, let's say inverse function for this part gets reflected something like here, because this will come here and this will come here. Now this part gets reflected something like this. Now, at that point, if you look at the vertical line test for this inverse function, is not going to hold true. So you can see that when I'm drawing the vertical line test for the inverse function, actually the inverse is not a function. Here, we can't say the given inverse is a function then, because it fails the horizontal vertical line test. So a function, which is a given relation, which is a function, its inverse may not be a function. You might just find a random expression, but that might not hold true. So what is the deeper thing that is required? So when you want to find out inverse, to find inverse basically, there is a test that we use called as horizontal line test. Or we say function must be one-to-one function. Now what does one-to-one mean? So one x value, if it is mapped against one y value, we call the functions one-to-one. In what cases it is mapped like that? So when your graph is either purely increasing like this or purely decreasing like this, this is called one-to-one function. And what's the horizontal line test that I was talking about? So if you draw a horizontal line and cuts the graph at only one point, it means that inverse of that function will be also an inverse. Also will be a function. So for example, here, second graph that we took, x squared graph, why its inverse was not a function? Because when I drew the horizontal line, you can see that it is cutting at more than a point. And when the graph cuts any horizontal line, when you draw a horizontal line and cuts the graph at more than a point, then that particular graph or relation which you're analyzing for inverse is not going to have a function. The inverse won't be a function. So this is the horizontal line test. And a general quadratic graph that we draw is not one-to-one function. That's indicated. Now, in such cases, like the questions in AS level are asked of top-notch level, where you can find out inverse of a quadratic with your certain of this understanding. So now, whichever functions don't have inverse, like for the natural domain, does it mean that they won't have at all? What we will do is we might have to restrict the domain in order to make the function one-to-one. And let's check how do we make the function one-to-one. Now consider this is the graph. Now this graph that you see is not one-to-one function. So if I draw a horizontal line, it cuts at more than a point. So what I can do is if I cut down this graph until here, if I say, okay, this graph, I'm just going to consider only this domain, then this function actually becomes one-to-one, and this is called restricting domain. Now, similarly, if you have a quadratic graph, let's say here and then here, this is not one-to-one function because it fails the horizontal line test. But what happens is that you can make it one-to-one by either cutting this side of the graph or by cutting this side of the graph. So then function actually becomes one-to-one. And those functions which you now draw inverse for, inverse will be something like this because it will be reflected in y equals to x line, will also be a function. So let us understand the entire idea of finding inverse of a quadratic, and that's our objective for this entire lesson. So now consider that there is an equation. Generally, the questions in AS level that they ask will be on the background of bigger picture will be to, it'll be like in a longer set of questions. Let's say they'll say f of x is being given as 2x squared minus 4x plus 3. Part A is going to be, let's say, write this quadratic in a x minus b the whole squared plus c format. And then they'll say, okay, graph this function, graph this. Then they'll say, okay, this function will have an inverse for a domain such that this function will have an inverse for x less than or equals to k, such that this is the largest domain. This is the largest domain, and you have to find the value of k. Find the value of k. So now when you want to do such questions and also find the inverse, like you have to find also the inverse of the function, you need to have multiple set of skills. Now in AS level, you don't need to worry about what method you're using for getting the values of A, B, and C. So what we do is straight away remember that we did many questions of this kind. Here, A that you talk about is the coefficient of x squared. So straight away, A that you get is 2. Now, what we do is we open this up, okay? So we open this and it becomes 2 times x minus b the whole squared plus c. And this is nothing but 2x squared minus 4x plus 3. It's the same thing I'm writing in this format. So what we do is after this, to make the comparison. So open up the bracket. So 2 times x squared minus 2bx plus b squared plus c equals to 2x squared minus 4x plus 3. Open up the bracket now. So it's going to be 2x squared plus 4bx plus 2b squared plus c equals to 2x squared minus 4x plus 3. Now, here we got 2, here we got 2. The coefficient of x here is minus 4. The coefficient of x here is 4b. So when I do that, so 4b actually is going to be equals to negative 4. So from here, I get the value of b as negative 1. Also, the constant term here is 2b squared plus c. 2b squared plus c is 3. Now if I plug b is negative 1 here, so 2 times negative 1 squared plus c is 3. So you get c equals to 3 minus 2, which is 1. So we got the entire values of a, b, c by doing this. So our final expression that we'll have is 2x minus 1 the whole squared. So b is negative 1 here. So x minus 1 the whole squared. My apologies here. So this is actually negative b. This is here negative b. So this is, so you get b as actually positive 1. So you get still c value is the same, but it is 2x x minus 1 the whole squared. It'll be 2x minus 1 the whole squared plus 1. So this is referred as the perfect squared form. For any quadratic, when you're finding the inverse, generally it is written to be, your equation has to be written in this format. So we are done with the first part. And now our second part is to graph this. Now when you want to graph this quadratic, now remember that if an equation is in this format, let's say 2x minus 1 the whole squared plus 1. So any graph in ax minus h the whole squared plus k format, always remember that h comma k is referred as vertex. Vertex, or it is also referred as turning point. Now, for example, in this question, just equate the bracket to 0. If I equate the bracket to 0, I get x equals to 1. So this part becomes anyway 0, and this is also 1. So 1 comma 1 will be the vertex. So when I draw the graph, for me, it becomes much more easier. So I take x is 1 here, y is also 1. And you can see y-intercept, where your graph cuts y-axis will be, if I plug x as 0, is at 3. So 0, comma 3. So if I draw the graph, and it's a happy phase graph because the coefficient of x squared is positive. So you could draw the graph of this particular quadratic with particular ease if you already have this vertex form. Now just another practice out of this context of the question is, let's say I have to draw graph of, let's say, uh, 2x plus 4 the whole squared minus 6. So here you'll notice that the vertex, if I equate this to 0, I get is negative 4 comma negative 6. So when you draw the graph, it'll be somewhere here, negative 4, negative 4 here, and negative 6. So this is where it'll be. And if I find the y-intercept by plugging x as 0, you can approximately sketch the graph for this without finding any other stuff. So this is just a general way to do it. And now coming back to this our problem where we had this one. Now you can clearly see that this graph doesn't pass the horizontal line test. So this is not one-to-one function. Now they're saying that this function will have an inverse for x less than k. So x less than k, what does it mean is that they are asking us to restrict this graph only from either left side of vertex, which is like here, it's like this. They want us to retain this side of the graph. So actually, in when you're finding the inverse of a quadratic, inverse will exist only one side of the vertex. Like either you take left side of vertex or right side. Here, since they have said that you have to take x less than or equals to k, so you take the inverse for the left side of vertex. So that means that when I'm finding the inverse, it's going to be for x less than or equals to 1, makes the function one-to-one function so that it passes the horizontal line test. If this part of the graph was existing, then it was failing the horizontal line test. So that's why we had to cut down the right side. And how did we know that we had to cut right side? From here, x less than or equals to k. So that is the possible value of k that we wanted to find out. And also it gives the largest domain. Now, why we say largest domain? We could have cut the graph even from here, from little to the right of 1, but it will shrink your domain. So that's why what we do is up till k equals to 1, my function is still 1-to-1, so I can extend till there. Now, last part here is that, okay, we wanted to find out what is the inverse of this function. Now, to find inverse, just use the perfect squared form, which we got, which is y equals to 2x minus 1 the whole squared plus 1. And so here we'll take is x equals to 2y minus 1 the whole squared plus 1. Make y the subject. So it'll be x minus 1 over 2 equals to y minus 1 the whole squared. Then you get y minus 1 equals to plus or minus root x minus 1 over 2. Bring 1 this side, so it'll be 1 here, and you'll get this. So y equals to 1 plus or minus root x minus 1 over 2. Now, out of the plus or minus, which one do we take as inverse? Which one is the actual inverse? So in that case, if you restricted, if you retain the left side of the vertex, your left side viewing angle, then in that case, it will be taken negative. If you retain the right side of vertex, then you take positive. So in our case, the final inverse that you'll have will be 1 minus root x minus 1 over 2. So instead of plus minus, because the plus part will be for inverse for this side. And what you got negative part, if you sketch it here, so your graph will be something like this. When you sketch the inverse, this graph that you got, it'll be something like this. And how I got that? By reflecting in y equals to x line. So this is the general idea of finding the inverse of a quadratic equation. So now this is the typical type of question that you'll be assessed in AIRS level for. So number one is when you talk about the finding out the, let's say, the format. This form you should be very clear with how do we convert in this form. So the first question is that consider the curve y equals to 8x minus x squared. Write down in the form a minus x plus b the whole square, stating the numerical values of a and b. Now, when you talk about the writing in this format, it is 8x minus x squared equals to a minus x plus b the whole square has been given to us. Our step is to just open this bracket, a minus, open the bracket, so with 2bx plus b squared. Now we make the comparison. So it'll be a minus x squared minus 2bx minus b squared. So if you arrange this in proper standard quadratic format, it is negative x squared negative 2bx plus a minus b squared. Now we have got the coefficient of x squared here. Now I would just rewrite here left hand side as well, negative x squared plus 8x. Now let us just make the comparison. We have coefficient x squared as negative 1 here, coefficient x squared is negative 1 here. That's all right. Coefficient of x here is negative 2b. So negative 2b equals to 8. That gives us b is negative 4. And then we got a minus b squared is 0 because there is no term here 0. So c is 0 and here the constant term is a minus b squared. So that gives us 0. Now you just put in the value of b, which is going to be a minus of minus 4 squared is 0. So that gives us a is positive 16. Now since we got a as 16, now our format, this format becomes 8x minus x squared can be written as 16 minus x plus b is negative 4. So it'll be negative 4 the whole square. So this is the format that we wanted to understand. So numerical values of a is 16 and b is negative 4. Hence or otherwise, find out the coordinate of stationary point. Now what is stationary point? Is basically, guys, stationary point is nothing but the vertex. It's also referred as vertex for quadratic, or also sometimes it's referred as turning point. Now why we call it stationary point is because it turns from here, and also if you draw tangent here, its slope is 0. It's a horizontal tangent, and that's why we call it as a turning point or stationary point, which we'll do more in calculus in detail. We don't need to think at this stage. Right now, we just learned about how do we get the vertex from this perfect square form. So equate this bracket to 0. If I equate this bracket to 0, I get x coordinate as 4. And because this is 0, I get y coordinate as 16. So the vertex is at 4, 16. So that answers our question. Hence or otherwise, find the coordinate of vertex. So that's 4, 16. The next part is find out the set of x values for y is greater than negative 20. This is now a little different question. It is a mixture of question. So we'll just do it for a quick recap because this is like quadratic inequality. So 8x minus x squared is y value. This has to be greater than negative 20. I can bring in everything either this side or this side. So I prefer to bring this thing here. So less than 0, I get x squared negative 8x negative 20. And now if I factor this out, basically I have to solve x squared minus 8x minus 20, where it is less than 0. So when I factor this out, what we get is basically we get negative 2 and positive 10. If you factor this out and find out the roots of this like sign diagram that we had done earlier, if you factorize this, you get x minus 10 and x plus 2 as a factor. Now what you just got to do is put one value in each interval. So I take 0 here. If I take 0 and I plug in here, so it'll be 0 squared minus 8 times 0 minus 20. It comes to be negative. Hence, the sign here is negative. And then here also, if you do, let's say, put somewhere like 11 or something, and you'll put here, you'll get this is positive. And similarly, here you'll get positive. Our correct range that we're looking at is less than 0 value. So when you look at the less than 0, this is I'm looking at less than 0. Now less than 0 is happening between negative 2 and 10. So that's my correct range of x values, which is, so I would write down x is between negative 2 and 10, both inclusive. So that's the answer for which y will be above negative 20. Our next part is state the domain and range for the function g inverse x. Now g inverse, first we need to find it out. So let us just first try to find out the inverse of this function. I'm just going to make use of everything that we have done to get the perfect square form. So I'm just going to erase all these parts, but I don't need them. What is the perfect square form I have written is here. That is the perfect square form that we wrote. We have written here is x minus 4, 16 minus x minus 4 the whole square. Now, since we just got to know that the vertex or the turning point is at 4 comma 16, and what we'll do now is that it passes through origin, because you can see the C part is 0, here C is 0, hence it passed through origin, and also it's 4 comma 16, so it's 4 and 16 here. So the graph of this function is going to be something like this. It passes through origin until here, and after this, the another part is this. It's a sad phase graph because the coefficient of x squared is negative. Now, they're saying is that we have to restrict the domain for x greater than 4. Now, when you say x greater than 4, it means you're cutting this part of the graph to make the graph one-to-one function. So obviously it becomes possible because you're now retaining the right side of vertex. So when I do that, if you look at here, the domain of the function that you see is actually given x more than 4. For this domain, my range become y less than or equals to 16, because you can see y is below 16. Now, they're saying that state the domain and range for inverse. Now, since we just learned that x properties of the inverse original function become y properties, so what we just need to do is, in order to write down the domain and range for inverse function, you just need to do one thing is flip the domain and range. So domain for inverse will become y, the range will become y greater than 4, and domain will become x less than or equals to 16. So this is how you write down the domain and range in case if you already know the domain and range for the original function. Final point is finding the inverse. Now, to find the inverse, you already got this format. We already got that a is, so you already got that this is y is 16 minus x minus 4 the whole squared. Now interchange x with y. So if I interchange, it will be 16 minus y minus 4 the whole squared. Then you bring y minus 4 the whole squared this side. So y minus 4 the whole squared is 16 minus x. Y minus 4 is plus or minus root 16 minus x. And then you get y will be 4 plus or minus root 16 minus x. Now out of plus or minus, now this time we're going to select positive. We're going to take a plus value, because since we are retaining the right side of vertex, it is going to be positive. So the final expression for inverse will be 4 plus root 16 minus x. And that's how you do this kind of questions, which is specifically asked in AS level.